Let us solve this question. The question says a tractor of mass 5.0 times 10 raised to power 3 kilogram is used to tow a car of mass 2.5 times 10 raised to power 3 kilogram. The tractor moved with a speed of 3.0 meters a second just before the towing rope becomes taut. Calculate Calculate the question 1. Speed of the tractor immediately the rope becomes taut. 2. Loss in kinetic energy of the system just after the car has started moving. Number 3. Impulse in the rope when it jacks the car into motion. This question is saying that a car which is not moving, this is the mass of the car, is being towed by a tractor that has this mass. All right. Now, the tractor was actually moving with a speed of 3 meters per second, but the car was not moving. If you want to solve this question correctly, you must know this. The law of conservation of momentum says that the total momentum before collision is equals to the total momentum after collision. Okay, so solution. The total momentum before collision, that is the mass of the tractor times by what? Initial velocity of the tractor plus mass of the car times initial velocity of the car is equal to. Now, the moment the rope becomes taut, both the car and the tractor will move with a common velocity. They stick together, correct? So that will be equal to the mass of the tractor plus mass of the car times by V. What is V? Common velocity. Question number one says the speed of the tractor immediately the rope becomes taut. All right. The moment the rope becomes taut, it means that the car and the tractor are now moving with the same speed. Okay, because they stick together. The rope is dragging the car. The rope is attached to the tractor and is used to tow the car. All right. So the car and the tractor now move with the same speed, and that speed is called common velocity. Velocity. All right. The mass of the tractor is 5.0 exponential 3 kilogram times the velocity, initial velocity of the tractor was 3.0 meters per second times 3.0 meters per second plus the mass of the car is 2.5 exponential 2.5 exponential 3 kilogram times the car was not moving because the car is being towed by the tractor. So it doesn't have initial velocity. So the initial velocity of the car is zero meters per second is equal to the mass of the tractor is 5.0 exponential 3 plus mass of the car 2.5 exponential 3 times their common velocity v. All right, so this is the step one. Step two, you work out this 5.0 exponential 3 times 3. Okay, this 3 will multiply 5 and it will give what? 15 times 10 raised to power what? 3 kilogram meter per second. All right, because this is the unit. Kilogram times meter per second will give you kilogram meter per second. Now, this times 0, anything times 0, any number multiply with 0 is what? 0. So this is plus 0 is equal to 2 point, this is 5.0 exponential 3, 2.5 exponential 3. Since the power of 10 is the same, using the law of addition of numbers in standard form, we can easily add 5 and 2.5. Since the power of 10 is the same for both. So that will be 5 plus 2.5. That will give us 7.5 times 10 raised to power 3. V. What are we looking for? We're looking for what? The common velocity. So therefore, our common velocity is 15 times 10 exponential 3 divided this one divided by this 7.5 exponential 3. Okay, so this side we cancel. 15 divided by 7.5 is 2. So it's going to be 2 meters per second. That's the common velocity. And that is answer to question 1. Okay, because question 1 says the speed of the tractor, immediately the rope becomes taut. This is the speed. The speed of the tractor, the moment the rope becomes taut, is also the speed of the car. That is why it's called common velocity. Question number 2 says loss in kinetic energy of the system just after the car has started moving. Now, the loss in kinetic energy, it is what? The total kinetic energy before collision minus the total kinetic energy after collision. All right? That is loss in kinetic energy is equals to what? Total initial kinetic energy minus what? Total final kinetic energy. Now, initial kinetic energy, the formula for finding kinetic energy is what? Half mv squared. Okay, so the total initial kinetic energy is going to be kinetic energy of the tractor plus kinetic energy of the car. Then the final kinetic energy is kinetic energy of the tractor and car moving together. All right, so we have 1/2 the mass of the tractor times the velocity of the tractor squared plus mass of the car times velocity of the car squared minus these two. We add them together because both of them forms our initial what? Total initial kinetic what? Energy. Now the total final kinetic energy is going to be 1/2 into the mass of the tractor plus mass of the car times common velocity squared. Right? Because after collision, the two vehicles now move with the same velocity. Okay? So here, the mass of the tractor is 5.0 exponential 3 times 5.0 times 10 raised to the power 3 times the velocity of the tractor. The tractor was moving with a velocity of 3. 3 squared minus the mass of the tractor is 5 exponential 3, while the mass of the car is 2.5 exponential 3. Their common velocity is what we just calculated, which is 2 meters per second squared. So that will be times 2 squared. Alright, now 2 can cancel this one, cancel 5 to give us what? 2.5. Alright, 3 squared is 9. 3 squared is 9. 9 times 2.5. 9 times 2.5 will give us 22.5 times 10 raised to the power 3. Look at 10 raised to the power 3 here. Minus. This half, we cancel one of these two that are multiplying. All right. Inside this place is 7.5. 5 exponential 3 plus 2.5 exponential 3 will give us 7.5 exponential 3 times 2. That will give us 15 exponential what? 3. 22.5 minus 15 will give us what? 7.5 times 10 raised to power what? 3 joule. This is loss in kinetic energy. Because don't forget that the unit of kinetic energy is what? Joule. Then question number 3. Impulse in the rope when it jacks the car into motion. Impulse is what? The product of force times time. And it is equivalent to what? Change in momentum. That is total final momentum minus total initial momentum. But don't forget, the law of momentum has already said that the total initial momentum is equals to the total final momentum. Therefore, the impulse in the rope is going to be total final momentum minus total initial momentum. And that will give us what? 0 Newton second. Why is this 0? It is 0 because the total initial momentum is equals to the total final momentum according to the law of conservation of momentum. Thank you. Please do not forget to share. Drop a comment in the comment section. Goodbye.